Okay, let's look at the graph of y is equal to sine x. So if we look at the graph y equals to sine x, this is the basic sine cycle. Okay, it's the one that starts at 0, 0 and goes in the positive direction. So we can say that the key points are 0 and 0, 90 and 1, 180 and 0. At 270, we're at minus 1. And at 360, we're back at 0. The other important thing that the sine graph has is the midline. That's the line that divides the upper half of the graph from the lower half of the graph. This is known as the midline. Very similar to all the other graphs that we have done before, like for example, the quadratic one and the exponential one, the sine graph also works in the same way. If there is something being added or subtracted on the end, it moves it up and down vertically. If there is something being added or subtracted inside of the brackets, it moves it left or right horizontally. And if there's anything being multiplied or divided in front of the sine, these are your stretches and compressions. So if I look, this graph has gone down by 1. So we can say that this graph is y is equal to sine x plus 1. And this is a vertical translation down 1. If we look at this graph, it has moved from 0, 0 over by 1 space. And every space is 30 degrees. So this is equal to y is equal to sine. And remember, brackets lie, so x minus 30. So this would be considered a horizontal translation, right 30 degrees. However, we're going to soon discover that in trigonometry, we don't call it a horizontal translation. It actually has a special name in trigonometry. This is actually called phase shift. If I look at this next one, the graph would normally only go up to 1 and down to minus 1. But now it's been stretched up to 2 and to minus 2. So this is likely the vertical stretch. So we say y is equal to 2 sine x, and this gives me a vertical stretch of 2. Normally starts at 0, 0. It's moved to the left by 1 space, which is 30 degrees. So we say y is equal to sine x plus 30, because brackets lie to me. So this will be a horizontal translation, left 30 degrees. But shortly we will be changing this to the word phase shift. This graph has moved up 1. Normally it would be at 0, 0. It's now at 1 or 0 and 1. And everything is sort of moved up 1. So we could say that this is y is equal to sine x plus 1. So this will be our vertical translation, up 1. And of course, this one looks compressed. So we can say that this is y is equal to 1/2 sine of x. So this is our vertical compression of 2. Okay, so let's look at what effect each of these had on sine x. So if I look, A does the same thing it's always done. So A gives me my vertical stretch, my vertical compression, and it will have a vertical reflection in the x-axis if there's a negative in front. The other thing that A is, it's the amplitude. And the amplitude can be found by doing the max minus the min divided by 2. Or the amplitude is the absolute value of A. It just means that's the positive value of A. If you've taken physics, you'll know that it's like the magnitude of A. Okay, so it means we only use the positive. So we don't worry about if there's a reflection or not. Okay, so if there is a reflection, that's great. But the amplitude, which is how high it is above the midline and how low it is below the midline, is a positive value. It's a distance. Okay, if you have the graph, you can take the maximum value, subtract the minimum value, and divide it by 2, and you will also get the amplitude. H is known as our phase shift, and that goes left or right. K is our vertical translation, up and down, and it is also the midline. I can find the midline if I don't know it by doing the max plus the min off a graph and dividing by 2.